So why am I talking about multithreaded? Postgres, Postgres has been using multi-process architecture since the very beginning, really. And there's been discussions of the benefits of multithreaded versus multiprocess over the years. But why am I suddenly talking about multithreaded? This kind of started last year at the Ottawa conference in PGConf. There was a group of hackers in the hallway track, standing in a circle and talking about all the things that would be much easier to do if we were using multithreaded processing. I was kind of thinking this is exactly the right people to actually make the decision and make the change happen. So it's kind of silly that we're all there, standing and complaining to each other when, we could be actually fixing this problem. That's kind of when I realized that we might actually have a consensus that we're not actually happy with the multiprocess architecture and we would prefer to have the multithreaded architecture. So I followed up on that, basically said exactly that thing on the mailing list. I think we have a consensus that we would actually like to have multithreading, so let's do it. So I posted that to hackers with some rough outline of how that might look like, but really what I wanted to get at the beginning is to acknowledge that we would like to do this, and it's not before we start actually writing code. So just a quick recap. What is multiprocess versus multithreaded? So we use a multiprocess architecture, which means that when you connect to Postgres, we fork a new process, and the new process is connected to shared memory. So all the communication between processes happens through shared memory. But whenever you allocate other stuff, it's always backend local, like your backend process deals with that. So what do we actually have in shared memory? Well, there's a lot of stuff. So this is like a dump from one of the functions that initializes the shared memory. The vast majority of your memory in a typical server goes into the shared buffers. And when people are tuning the sizes of shared memory, they really think about the shared buffers, because that's where most of the memory goes. But there's actually a lot of small stuff used for all kinds of inter-process communication. There's all kinds of other buffers than the shared buffer cache for SLR use. There's all kinds of other data structures that are sized. The size depends on how many, your max connections and various other settings. But each of these is a fixed size chunk of memory allocated for each of these. And when Postgres starts up, it needs to decide what is the size of this data structure, and then you allocate that much, and that's what you get. So yeah, there's a bunch of other stuff, And then there's extensions too. Extensions also have this option. If you want to have an extension that uses shared memory, you need to put it in shared preload libraries so that it can run early at Postmaster startup and make that allocation. And after that, you can use it. But you have to know the size beforehand, which is very inconvenient. There is a mechanism called dynamic shared memory, which helps with this. So you can allocate shared memory afterwards as well, and you can choose the size. It's also very tedious to use. I actually struggled with this with PG Vector recently when we started to use parallel worker processes to build the HNSW index. You kind of have to make you have to make the giant allocation up front when you start the index build, and it's not easy to size it later. We have some facilities for that too, called dynamic DSA, dynamic shared memory allocator or something, which tries to do that, but it's all of this is very inconvenient to use. That's what I'm getting at, because with the DSA, for example, you can't have regular pointers because each process might have that dynamic shared memory mapped at a different address. So you have to deal with that, and it all gets very complicated. Possible, but complicated. And we have done all of these things that use these facilities, but they are always tedious to write. So in the multithreaded architecture, the way I'm imagining, there would be many ways to go with multithreads, but the way I'm imagining it and what I'm presenting here today is the model that you have one thread per connection. Not one process, but one thread. Everything runs in a single process, single address space, but you launch a new thread for each connection, and that thread handles everything that happens within that connection. So that makes it a lot easier to do all of those previous stuff I listed. you don't need to choose the size of your area beforehand. You can just allocate memory and you can pass it to a different thread. You can pass a pointer to that thing. You can allocate more and you can deal with that. So that makes a lot of things easier. In summary, like with the big difference between threads and processes in the way I'm describing it or imagining it is that whether you have a shared address space or not, and whether it's hard to share data between processes or between connections or threads, or easy. So why? Like, what are the benefits? The immediate benefits from doing this might be fewer TLB misses. I spoke with Andres Freund about that, and he brings up the point that you would get some benefit immediately just by switching the threads, even if you don't do anything else. Because it turns out that if you have a large amount of memory, I don't fully understand this stuff, but you would have a page table, like a kernel page table in each process, and it turns out it actually takes up some space, and like that is apparently significant overhead. I haven't done measurements to see that myself, but I believe that. Again, there might be other ways to do this, like there's been discussion on the Linux kernel about an mshare system call that would allow you to share the page tables between processes too, but that doesn't exist yet. Maybe it will in the future, but again, multithreading will just give you that. What I'm really more interested though is like not the short-term, performance gains, whatever, but all of these other things that become easier to do in a multiprocess architecture. You won't, once we switch to threads, just do that. We won't get any of these immediately, like they will not automatically happen, but it makes it possible or easier to do all of these things. You can, forking a thread is cheaper than forking a process. You can do more cheaper connections. You can, it will help to do a built-in connection pool or not need a connection pool in the first place. There's a lot of other reasons why that would still be slow, and we need to kind of fix those too. It makes it easier possible to have a shared rel cache. It won't happen automatically. You would still need to actually build that and make it shared and then add locking there so you can share it safely. But again, at least it becomes possible without, if you would want to, otherwise the way we would have to do it is to allocate a fixed size, another fixed size segment for the rel cache, and you need to tune that manually and whatnot, and that gets hard. Same with plan cache, catalog cache, those all kinds of little caches in the backend and they actually consume quite a lot of memory. This is people run into this sometimes when you have a large application with thousands of functions, for example, PGCL functions or something. Each connection, each backend process actually consumes quite a lot of memory, like many megabytes, and if you have thousands of connections, that adds up. Like you can consume gigabytes and gigabytes of memory just for all the local, like duplicated caches, which for some applications, that's very significant. Just making it possible to resize some of those areas that are currently fixed size, like shared buffers, lock table. Again, won't happen not just automatically, but at least makes it possible and easier to resize those things. Or changing some settings without restart. Another, track snapshots that are in use. That was just one very specific example where I remember I ran into this problem, is that it would be nice if a vacuum could know what snapshots other backends have active. But there's no fundamental limit to how many you can have, so we would have to, again, allocate a fixed size chunk to hold that. But with multithreading and the shared address space, that would be a lot easier. You could just let it grow as you need. Another one is like explain, analyze on the fly. You could imagine peeking at that other connection's data structures from another connection and do stuff. Limiting memory usage per session is another one. Like Postgres' memory management is pretty, it's like, absent. That's one way to say it. Like, not well defined. Like your one backend can consume all of the memory. There's no way to put a limit on it. And we just rely on the operating system to eventually give you an out of memory error, but that might not be what you want. Again, it will automatically happen with multithreading. In fact, it might get worse depending on your workload, but it gives us more tools. Like then, because otherwise we have this issue where one backend can allocate a lot of memory, use some of it, But we don't actually have any control of when the memory gets given back to the operating system necessarily. So you need to play with malloc implementations and so forth to really keep track of that. So probably would get easier with multithreading and the shared address space. So the objections, why is this a bad idea? I went through, on that hackers thread I started, I didn't comment very much. I replied to a few of them, but I listened very carefully. Like I actually paid a lot of attention and cataloged all the objections that people came up with and kind of categorized them into 4 different categories. I'm going to cover the first 3 first. First of all, it's not worth the effort. Well, yeah, okay, then if it's not worth the effort, then it probably won't happen because no one will finish it. But I kind of ignore this objection actually because it's the wrong question to ask in an open source project. Like, I'm not going to tell you how you spend your time, and it's none of, you shouldn't be telling me how I spend my time. If I did worthwhile, then whatever. So I'm going to move on. Too much incompatibility, like we don't want to end up in a Python 2 versus Python 3 situation where we kind of have a hard break and then people will stick to Postgres 17 because that was the last version that had a multiprocessor or whatever. That's a bad situation. I don't want to end up in that. I don't want to fragment the whole ecosystem. I don't want to have massive disruption. There's also very subtle stuff like if you today Google for an error message that you get in Postgres, you will immediately find 10 blog posts about that error message that explain you what you did wrong. I also don't want to disrupt that by changing too much. I want us to be still the same good old Postgres that people know how to operate. The settings still do roughly what they did before, and I don't want to have any unnecessary change as part of this project. The second objection is the one from Tom Lane, which he posted half an hour after I started the thread. I mean, it's kind of hard to argue against that. I hope it's not a disaster. I hope there won't be that many bugs. I mean, you could say that for any project. Anything can go wrong. But we've done big changes before. We have introduced parallel queries. We have done big invasive changes. If we think it's worth it, it's totally doable. We write the tests we need. If we have a patch and it turns out that there's a continuous stream of bugs in that patch, then we won't commit it, or we will more label it as experimental or whatnot. But this is we can deal with this. This is a problem that we can deal with, and it's not that different from any other project we do, I believe. Also, the ecosystem has actually gotten better. There was if you go back 20 years, there were a lot of different implementations of threads on different platforms. They behaved slightly differently. There was a lot of library support missing. So I think there was actually, a long time ago, there was much more potential for that kind of subtle stuff that we would not like to have. But today, multithreading is the default architecture. People go for a server software. It's not something exotic or special anymore. Multiprocess architectures are getting more rare. That's actually, I think we're more likely to start to hit that kind of issues with multiprocess than multithreading going forward. So I think the situation has become better. If you look at our tools too, like libpq, OpenSSL, there used to be functions that you had to call if you're using threads, but all of that is kind of gone now because all of these libraries just work in a multithreaded environment. So all of the 3 previous objections were kind of reasons why we would not want to switch to multithreaded architecture, but this last category is different, and this one I actually take more seriously. This would be if we were using multithreaded architecture today, this is the kind of category of arguments that we should actually switch from multithreaded to multiprocess. It's actually better than what we have today, or than multithreaded. So if there are a lot of reasons like this 4th category, then we will be losing that isolation or whatever benefits we would get from multiprocess and forever. And there might be a lot of reasons people would actually want to have both models, And I don't want to actually be in that situation for too long, at least. So let's look at this. Yeah, I mean, multi-process architecture gives you more isolation. Each process has their own address space. That's nice. Good example, Chrome uses process per tab, and that's for isolation reasons. If one tab crashes, it doesn't crash your whole browser, and you know.
You can still roll up processes, though, I think, right? Like,
probably.
there's like a mix where it's like tabs, it will end up with like multi-tab per process.
Probably, probably true. And that's kind of what I'm getting at with Postgres. We're not actually getting much isolation in practice. Like, this is not very serious isolation we're getting today. Like I said, like a vast majority of your memory is actually shared buffers, and there's a ton of all that list of stuff that we currently keep in shared memory. Like, all of that is already shared, and if you screw up any of those data structures, you're in trouble anyway. In fact, if you just randomly kill a process in Postgres, like kill 9, kill a process, Postmaster will kill all the other processes too, because you don't know what state you are in. So you're not actually getting, I argue that you're not actually getting much isolation. Like, this isn't significant. So another similar argument is that like multiple processes might be easier to work with the debugger, strace, top. That's maybe true, at least for a while. Like, I find it, I'm very convenient or used to using debugger in Postgres with multiple processes and strace and so forth. But people get around, like, I think that's just me, because I'm used to working with multi-processes. Like, people work with multi-threaded programs all the time, and all these debuggers and tools have they have the options and tools to work with threads as well. So, we'll get used to it. Memory leaks will be worse. Today, if you have one backend that is leaking memory for whatever reason, you kill the backend, like you exit the connection and you start a new one, and that cleans up your leak, which is nice. This is true. Like, this is a serious objection. Like, in a multi-threaded architecture, if you leak memory, you leak it until you restart the whole server, or file descriptors, or whatever other resources you have. There was a leak until recently. I think this was fixed in September last year or November, around that time. We had actually one pretty long-running leak like that in LLVM, like with JIT compilation. That was fixed. Like, we fixed that. In general, I think this is okay. I don't think we'll have like too much trouble. We do have memory leaks every now and then, but there are almost always memory leaks into a memory context that is long-lived, like either a session context or the transaction context or something. And we fix those. And this would be no different. This would only be the case if you actually use malloc and bypass the whole memory context system, or you don't use the resource owners to track your resources. So I think we're doing pretty well in Postgres about this. Like, I don't remember, that LLVM leak is actually the only one I can think of for a long time where we have had the kind of leak that would be a problem, or would we get worse if it was just a single process with multiple threads. Multi-process architecture enforces some discipline. Like, you really need to think about what data structures you're sharing and how you're sharing, and choose the size for them, which, yeah, it forces some discipline on you. Like, you don't just, go and allocate tons of memory and let your data structures grow. But it's also very painful. Like, I don't think we want that much discipline. And there would be other ways of doing that. Like, there are other ways of being disciplined than forcing the multi-process architecture on you. It's kind of the summary of the objections. Before we move on, did I miss anything? Yeah.
About the memory leaks, we are quite good in Postgres, but we have extensions. And I have seen a few times in PostGIS, at least, these slow memory leak things, where the only solution, because PostGIS has lots of different other dependencies, and all they do mallocs, and they are all over the place. And when you update your system, then you never know which one gets updated and now has a leak. So it is not just Postgres, and it kind of helps to protect against these things.
I think that's fair. The libraries in general these days, they are usually designed to work in multi-threaded architectures, and like everyone else is kind of having the same problems. I'm not too familiar with PostGIS, and I know they depend on a bunch of libraries.
There's nothing to do with the fact about multithread. It's just when the leak comes in some version, and then another leak in another version, then currently we have a very easy way to get out of it by just limiting the connection lifetime. Every now and then you reconnect, and then you will fix it.
That's fair. I think that's true. Like I think it's still worth it. Libraries will fix these leaks when we report them. Some libraries have hooks you can plug your own allocator into them. Like different libraries all the libraries are slightly different on that, but.
Yeah, I'm not saying at all that it's unsolvable problem, that suddenly you have a library with all the leaks, but it doesn't happen tomorrow. It may take a few weeks at least to get it fixed, and then you have to live with it somehow.
I think that some of the gains are overstated because some of these caches, so to speak, like the system cache and sort procedures or functions, they don't change in the middle of a transaction. So now every transaction basically needs its own copy of it. You can't exchange the code of a store procedure in the middle.
Right, but that doesn't mean you have to have a complete separate copy for each session. That just means you need to have some scheme for
Copy on write.
conversion, right? Yeah, something like that.
Copy and write reference counts. Yeah, there are ways to do that. So,
One place where I think we do depend on process isolation is the assumption that the postmaster will not be taken down by a backend crash.
Yes.
So you probably still want some kind of separate babysitter process, maybe.
Yeah, I agree. I've been thinking that we would have two processes. What you call babysitter postmaster process, which doesn't do anything else than restart the actual postmaster process. Don't crash.
Isn't there any kind of security concern moving from the isolation process to multi-thread?
Not really. Like this comes down to it's the same as with crashes. If you have a security issue or vulnerability that lets you, write arbitrary memory, it's very easy to get out of the process anyway, and you can access all of the data within your, any process anyway. It's not really.
So you mentioned that you wouldn't be able to use strace and stuff like that. You need to use debuggers with threading.
And strace probably has.
Right. Now, one thing that I could think of being a significant problem here operationally is that many places are happy with strace going on production servers. They're not happy with debuggers going on production servers. And this is something which could end up imposing an operational cost.
But you can strace threads.
Yeah, I'm gonna stress the first.
You can. I don't see a problem.
One advantage that hasn't been mentioned is that in a multi-threaded architecture, it would be very easy to basically park your client connection at a monitor thread and see if it's going away aboard the query. If there is a cancel message pending, you don't need a second connection. All these things become easier in a multi-threaded architecture. I like it.
I mean, from the debugging point of view, debugging at the moment can be a pain in the neck because you've got to make a connection and you've got to find the back end.
Yes.
You've got to debug it to it and so on. Whereas if we've actually got a fixed server process, you can make multiple connections and trace them as they go.
Similarly with
much more easily.
Similarly with debugging parallel query, right? Like debugging parallel query is obviously difficult multiprocessing.
Yeah, I think all of this debugging thing is more about like what we're used to, rather than it's not objectively better or worse.
Did you have more content? Because we seem to have entered the...
but this is an important point. There is more content, yes, there is more on actually how do we get there and so
I was
forth.
going to make a comment on that. The first one, actually, it's not worth the effort one. I wonder if that objection is not so much someone saying it's not worth you spending your time on it, so much as reading between the lines, they're saying you are going to impose a very high tax on the parts of the system that I maintain. Like I have to relearn all the parts of the system I maintain.
That means that it's effectively actually the second point here.
Right. But internally as opposed to externally.
Any other completely new kinds of objections that I have missed?
I think I have a new one. So it's interesting, your analogy to parallel query. One area where I see that break down is in parallel query, all existing functions were parallel unsafe until they were modified. So parallel queries didn't take effect. But if I'm the maintainer of some procedural language that has a the plan cache similar to how PGSQL has its cache, it's not optional for me to modify that before it works with this threaded one. And we can't have a threaded unsafe that causes the backend to go process-wise again.
That's true. So in effect, if you have an extension that isn't thread safe, then you just can't use it. You need to actually go and fix it. That's fair. I think that goes into the second category, really.
Question about the third category. What are your feelings about avoiding lots of bugs with just a better test suite? Right? I mean, do you think that's a reasonable thing? Instead of just hopefully a lot more bugs.
Sure, more tests is better. Right now, I'm not sure what kind of new kinds of tests would target this in particular. I'm all ears for ideas. What is the good testing strategy? Oh, excellent.
How do you think that this change will impact extension code bases? For one, I do think that from my research, I found that a decent portion of extension bugs are actually caused by either background worker problems or shared memory problems, both of which would actually be solved in a per thread model, because then you could just use the pthread utilities and malloc, which is what other extensibility systems do. However, I do think that this is kind of like a naive saying, oh yeah, if we do this, it'll be easier, but you've actually never done this switch. So I'm asking you, what do you think are anticipated extension bugs or code problems in terms of converting?
So in the short term, not much changes. You can't just automatically, even when we do the switch, you can't just naively start to spawn threads to do stuff that. There will still need to work with all the locks and other stuff we have. And I also still wouldn't recommend you to just use malloc to allocate memory. You would still want to use the memory contexts we have and so forth. So in the short term, not much changes. But in the long term, it will be easier to write your extensions too. That will, instead of having to allocate the shared memory stuff, you can just allocate memory and pass it around more easily. So I don't think the impact to extensions is going to be very large in the beginning, but it will give us also options. I actually think that pretty soon, if we start to have this option, during the transition period, I'm imagining, we will start to see extensions that only work in the threaded model because it's easier to write some extensions that way.
Cool. Thank you.
All right. So there have been a few other previous attempts at this. There was an early Windows port. I couldn't find a link to that, but I remember that there was an early Windows port somewhere. I don't know if someone knows the details. That did this, for Windows, because Windows doesn't do fork the way Unix systems do. We didn't take that approach back then. We went with the other approach that we still use today, which is you fork a process and you exec, or in Windows, you just you create a new process, completely separate process, and then you kind of attach it to the shared memory segment, and then you initialize the variables that are usually inherited from the parent process. You initialize them. That's actually another nice thing about this. I think this will make the Windows port less painful because it will be more similar to the rest of the code base. It's not a huge maintenance overhead, but it's always there. It's always causing a little bit of friction. There was another one. I don't know how far they got. There was a project someone pointed me to called Peloton. Then there is I recommend if you're interested, I recommend to read it. They did a pretty good write-up of their findings of what did they have to do to make Postgres multithreaded. They also started to use C++, and there was another half of that article is about the pain they got from switch to C++, and the other half is about the pain they got from going with multithreaded. I don't know. I haven't seen I don't know if they ever finished it or not, but it's pretty good write-up, and it's the same stuff I ran into, researching this, that they also identified. The third one is this is from a colleague of mine, Konstantin Knitschnik. He was working at Postgres Pro at the time, so he actually wrote a quick prototype of that. Just changed all the global variables to be thread local, and then replaced the fork call with POSIX create and then kind of fix the rest of the stuff until he got something working. So this can be done. It's another example. Never productionized that, but it's there. There are other projects that have made this switch. There's Apache. There's, Oracle has multiple models you can choose. I don't know the details. There's Firebird, formerly called Interbase, a long time ago. I think they started with a multi-process architecture, then they introduced threading support, and I think they still support multiple models. What's common with all of these is actually, I think these all still support both multi-process and multi-threaded architectures. I don't want to end up in that situation. I think if we want to do this, we should decide that we want to actually switch and get rid of the multi-process architecture over some transition period. Because otherwise we are still paying all the cost of the multi-process. We still need to maintain all that. So here's the plan. This is how we're going to do it. In short, we replace the fork call with PostgreSQL create. So instead of forking a process, you create a thread. Yeah, that's a one-line change. I've done that. Not a huge problem as such, but it's just a lot of code churn that we find. We have a lot of global variables, which are currently per process because that's how it works. And we used global variables to store all kinds of per session state. All that rel cache, system cache catalog, all of those are, at the end of the day, they were like a global variable somewhere that points to a data structure. There's a lot of that, like thousands and thousands of global variables. I think like 2,000 or 4,000, something like that. I counted them. So they will all need to be, we need to go through all of them and decide this is the kind of global variable that needs to be turned into a thread local variable because it's all stored in session state, or is it a pointer to a lot of these are pointers to shared memory structures, which are actually, they have the same value in every process today, so they can stay to be global variables. One thing we'll need to do is with the extensions, like there's going to be a transition period where extensions will need to, not all extensions will make the switch at the same time as Postgres core does, so we'll need to wait for the extensions to declare that they are thread safe, that they work in the new model, or they work in both models, or they only work in thread model, once we start to get those. And then there's a few subsystems we'll need to rewrite like fd.c has, file descriptors are currently per process. There's a few of those. That's the plan. I'm going to dig into a few of these points a little bit more. So I mentioned the session local state currently in global variables. This is what it looks like. My plan is that we will annotate all of the global variables with something like that, which says, what kind of a global variable is it? And there are a few categories of these. There are thread local stuff like GUCs like search path, for example. They are really tied to the session. Then there's stuff like plan caches that are also kind of tied to the session, but are not necessarily user visible. I don't know if there's a real distinction there. Then there's stuff that are like variables that are initialized at postmaster startup time and then inherited by all of the child processes. Or on our Windows port, we currently reinitialize them in each of the process. And there's a mechanism to save them in a file and reload it on file and stuff like that. But in a nutshell, like there's a class of global variables that those ones can stay global variables in the future as well. We have a few global variables that are actually read-only, like initialized on the first use and then never touched again. We have a few global variables that are actually constants, and we probably should mark them as constants. But like there are like 4 or 5 different categories like this of different global variables. So I propose that we label them all, like we add annotations to them all, so that we know that we have thought about them all, like we have considered each one. And this is something that extensions will need to do as well. So the extensions have, they do the same thing. They will have global variables that point to session local state. They will need to do the same annotation on all of the global variables, like, what does it actually do? For this, Tristan, a colleague of mine, Tristan, wrote actually already a little Clang plugin that will print a list of all the global variables that don't have the annotation like this. So there is a tool, or we can probably polish it a little bit. We can have a tool that gives you like a to-do list of what variables did you miss, and that will be very useful for the extensions too. So we can write a tool that catches at least the most common mistakes or the most common things that will be breaking extensions and check them if it's thread safe or not.
Are there advantages to making all of these individually thread local variables versus having like a big struct where you just have one thread local variable pointing to your struct?
That's a good question. Like one big struct would be appealing, because then you could imagine in the future that we could like move that between threads as well. We could imagine having a thread pool instead of having one thread per connection.
You can peek at someone else's variables.
Yes, you can easily see all the states. So I think there would be advantage to that. It's a bit tricky, especially when you start to consider the extensions, because how would you add your extension stuff to that one big struct? You need to have some kind of allocation mechanism for that struct thing now, and something. Yeah, I don't know, but it gets a little bit complicated. I think the easiest way to get started is to go with thread local storage or thread local variables, because then the compiler will, then linker or whatever, I'm not sure how it works, but they will effectively do that for you.
Yeah. The big advantage is you don't have code churn in the reference of super variables.
So, isn't this like the anti-pattern what we discussed? Like there are some books which are shared, which need to be shared across all the processes, and now and those values can be either session level or global level. So when they are global level, it makes sense to have a global variable. But for session, we need session level code. So aren't we going backwards now? That we created threads so that that global state can be shared.
Right. So there are a lot of GUCs that are like postmaster GUCs, or like they are supposed to have the same value in every process. Currently, you can have a situation currently in Postgres where you send sig hop to one process, but not the others, and they can actually have different values, but they are supposed to converge over time. So I'm not sure what to do about that. I think the short term, the simplest thing we can do is to still treat them all as thread local and like keep the current mechanism we have to synchronize them. It would make a lot of sense though to just have a global variable and have each thread read the same variable, but maybe we should go through all the GUCs and see for which ones it makes sense, like which ones, some of them might break if the value changes like at the wrong place.
Yeah, I think some of them are transactional, so actually, when you can't just go and change them.
Some of them are, those are like session level GUCs, but there's a bunch of, I don't have any examples in my head, but like there are some GUCs that you can change at the, for the whole server.
The postmaster, a running transaction, only gets to see the changes after going through the TCOP.
Well, there's some cases where that's an annoyance, and
yes,
where it's good.
Right. Debug level.
Right. Yeah. Ideally, we would go through each one of them and kind of make the call on.
But yeah, that could happen later.
So, extensions. I said like extensions will need a transition period. For the core, first of all, I think what I'd like to have is a transition period that is short as possible, because it's painful to have both models. So ideally, one release, probably not feasible. Maybe 2 releases, 3 releases. We'll see where this project goes. How comfortable are we with making the switch for good? But the extensions will need a transition period too, like independently of Postgres. So I'm imagining that we will add a flag to the control file, so you can see easily which extensions support processes or require processes, which ones require threads or work in both models. And I mentioned the tool that would go through the global variables and extensions too. Like, let's make that available. If there's something we can do to test for concurrency issues, I don't know what exactly that would be, but like some kind of tests would be nice. But that's my plan for extensions. We have made, it's not nice to break the world of extensions, but we actually kind of do that. If you look at any popular extensions, there's a lot of if-defs of PG version. It's not like we'd never do this before. As long as it's not too painful for the extension authors to adapt, like this is fine. We've done this before. We changed rel file node to rel number, and we make changes in every release. And some of them are more painful. This is probably more painful than many others, but it's manageable. Extension authors are used to dealing with this kind of stuff.
Do you think it would be possible to maintain the backward compatibility of one extension for threads and processes, though? Because for the older release, like a lot of extensions will support multiple Postgres majors, right?
Yeah.
If that's
So for things like index access methods or something, or data types, it's going to be easy. But for things like PL Python or PL Perl,
PL Python.
Wait, no. Sometimes index access methods have like background workers.
yeah, okay, maybe not all of them, but
Yeah.
like my point is exactly that. There's going to be, are there not going to be some types of extensions that just can't do that?
I mean, if it's a UDF that only uses like a CUDF that only uses like what's it called? I guess it's just like a map UDF or something. It's just like float arithmetic or something. That's kind of like trivial to change, and it doesn't need to be.
Or it doesn't need
I
any.
think really anything that uses shared memory or background process is going to be really difficult to change.
Or has its own threading model that's not
Different, yeah.
I mean, some of this, like if you just use a piece of shared memory, that doesn't necessarily need, you don't necessarily need to change anything. You can still, I would imagine that we will still, for backwards compatibility reasons, still have the functions to allocate shared memory, which would really just be a malloc at that point. But you could still continue to use it that way.
To Joe's point, though, you can take an existing global, declare it as thread, and then still use it in the process architecture, right? It's just a thread variable within that process. So in terms of keeping compatibility with the extension, with older majors, the extension should be able to, once you make them, workable on the thread.
Yeah. I just know from maintaining multiple extensions over time that just allowing the extension to work with different majors is really painful. I'm just trying to imagine how much more painful it would be to support both processes in the older majors as well as threads in the new major.
Also, we make presumptions about it being process-based in the extension, right? So a whole bunch of stuff like that where the presumptions are no longer valid, right?
It depends on your, it depends. If PL Python, PL Perl was mentioned, I know for a fact that Python used to not work. They actually, there's a part limitation that you would only have like a single Python interpreter in the process. They fixed, I do need to look up, but I think they changed this. So recent Python versions do support having multiple interpreters in a single process, so they would work, but we would probably need to bump up the minimum version requirement for Python. Perl, I think, works. I'm not aware of any other ones that would be really hard.
Are you saying that recent Python interpreters allow multiple Python interpreter threads to run in the same process, or?
That, yes.
Okay, so they still internally have a GIL, they're just as a thread.
That's a separate thing, yes.
I think it might be a better idea to have the slag and the magic block with the dynamic library.
Yes, yes, I agree. Like the magic block would say.
Yeah, if you put it in a control file, there's a real problem with being sure the control file matches the .NET. So
yes, I think you're right. That would be a better place to do that. And also then if you don't run the alter extension command,
So as far as ones that might be difficult, I know that there are still some users of things like PL Java. Since PL Java has its own threading model and own sandbox model, do you foresee that to be difficult or easier in this case? Oh, it'd be way easier.
You could do it both ways. I could imagine that you just don't change anything and then it will maybe just work, but then you will have multiple Java interpreters in the same process, which might or might not be what you want. Then you would have the option to have just a single interpreter running. Right, just one JVM for the whole server, which, that might, if you do the work and make that work, that might be much nicer in the end. It's work. Yeah, it doesn't fall out of this automatically.
So the first point you had that you ignored, which was, is it worth it? Have you defined what, I agree with ignoring that, but have you defined what would make it work?
If I can get all of you other people to work on it, that would make it totally worth it my time.
One thing missing on other projects that did this, so in the Sybase engine, we were always process-based, using green threads. inside processes, and then led a project about 10 years ago to switch to multi-threading. And it was largely for the same benefits around, well, mostly for network related benefits, because all the file descriptor stuff it was pretty successful. Having all the globals in a shared session structure made it much easier. Like that was really good. But it was worth it. It yielded a lot of improvements and just made a lot of the stuff that was always a pain in the ass because the process was better. And we did, for risk mitigation, have actually a runtime or boot time flag process or threaded, and it stuck with that for a while.
I guess my question is more about performance. So, like, let's say that the threading model is performant for some workloads, but not for other workloads.
Yeah.
How do we measure? What's the criteria for?
I can't imagine a workload where the multiprocess architecture would be so much better that you would care.
You still have one GIL now in all these threads.
I don't know. I'm not too familiar with Python. I would imagine that if you have multiple interpreters, each one of them would have their own GIL. I don't think there's a difference there. But we'll figure. We'll test that.
Yeah, they got rid of the GIL optionally anyway. So
they did.
Yes.
Yeah, but everyone still uses 2.6.
Well, then they can use Postgres 9.6.
Right.
So. Talk about extensions. There's a few other things we need to do, like there's a few subsystems that we need to rewrite. fd.c, it's kind of straightforward work. One big one is we use signals between processes today a lot for all kinds of stuff. Signals are painful with threads. Like if you send a signal, you send it to the process. I think there's some specific calls to send it to a given thread, but then it's kind of arbitrary which thread receives it and handles it. So I think we'll need to rewrite that part, and that's one of the refactoring efforts I'd like to take on next. It's kind of messy anyway. I think we can clean up the code, ignoring all the threading work, like refactoring this the way we use signals might be a worthwhile effort anyway. Then, of course, how we launch connections. We talk about having babysitter process for Postmaster. There's stuff like that we'll need to rewrite or work differently with multithreaded.
Using per thread variables, is that actually going to work when you do things like have an extension that starts new threads and then those threads try to use SPI, for example? Well, they're going to have their own set of...
It won't automatically make that work. That won't work today. And this won't automatically make that work. I think there is a much better chance of...
That's not true.
No, that won't work today.
So say again.
So if your extension starts a new thread, yes, and that new thread tries to use SPI
with
and
interlock,
with a lock, so you're doing it safely.
Oh, I see.
So now those little variables are going to be per thread.
I see what you mean. Yeah. Okay. Yeah, I think you're right. We'll need to figure out how common that is. And
you put them all in a session block, and then you reference a session block.
Yeah,
and to keep it
that's
easier.
That's still a per thread thing, but it's easier to manage.
You can set it up and make it work. And then Tom's point about the references is spot on. But we could so you put everything in a structure, put some annotations, and have code generate pound finds that use the old variable names and a pointer from the global struct, and now you.
That's a good point, Bill. That is one incompatible. If there is an extension out there that uses SPI, but sometimes it calls it from one thread and sometimes another one.
PL Python will have, or PL Java will support it.
So you could imagine that you delegate it all to one thread.
You say SPI, but it's any Postgres API call.
Right. Yeah, that's a good point. We'll need to try that, how big a problem it is. We're running out of time. There is a transition period, the first version will be buggy, we'll fix the bugs. Extensions need time to catch up. I said earlier, I want to keep this short because this is going to be a painful transition period. Hopefully not longer than 2 years. We'll see how long it takes. How long does it take until we are comfortable with switching? And once we have the guts to change the model, some people will start to use it, and then we'll arrive at the place where a lot of people are using it, and then we're comfortable.
Do you really see this as being a single build fix?
Yes, I would like to get to that point. The other option would be a compile time option, which I don't think there's much difference in it's whether it's if def or if, in all of those places.
Sorry, real fast, because we're out of time. There's a coffee break next, so we can probably go like 5 or 10 minutes over, but can we let Heikki be?
Thanks.
And then we can talk from that side.
I'm almost at the end. So I think we need to get, my goal, what I want to accomplish is to get rid of the multi-process mode as quickly as possible. There's going to be a transition period though. Yeah, I would imagine that it's a GUC. I'd like to make it a GUC. That makes it more easy for people to try it out and see if it works for you or not. I think you will get a lot more testing of it that way. So once we've done all this, like we'll be in the brave new world, we can start to use, this will benefit parallel worker stuff. We can allocate things more easily. There's more stuff that I don't want to do, at least not initially, but we could imagine doing, but this is kind of out of scope. We could switch to using thread pools rather than a single thread per connection, with kind of queuing stuff. There's other databases doing thread per core, like that's all the rage nowadays. We could do that kind of stuff. Async execution, so it's a whole new, different can of worms, but I think that would be easier probably once we've made the switch. But this would be all out of scope. Add-on stuff add-on big projects that we might or might not do in the future. So where are we today? I did a little bit of refactoring in 17 around fork and exec, which was nice anyway, but it was kind of the first step, not very far. I've done the work together with Tristan to annotate all of the global variables, and we kind of have a rough sketch of that. It's out there if you want to take a look at it. It's like 2,000 or 4,000 lines of code churn. But this is basically, we talked about a lot of these things already. There is a list of stuff that we'll need to do. Some of these are painful. Some of these are just kind of sideways movement unless we actually go with the threads, but not too painful. I put up a wiki page on the Postgres wiki just yesterday, like gathering all of these thoughts. And there is a to-do list there if you want to look at, if there's something, if you want to help, like pick one of the items and let's try to get this moving.